After successfully completing this lesson, you'll be familiar with head-to-flow curves, power-to-flow curves, net positive suction head, cavitation, and how to prevent it. The lesson will end with a test, and your score will be recorded. The performance of a pump is shown by its characteristic curve, where the flow capacity is plotted against the delivery pressure, or developed head. Head is measured in meters. The static head is the difference between suction head and delivered head. As the suction head changes, the static head changes. When the pump is operating, the liquid will be moving within the pipework, and so a loss due to friction will occur. It's time for a quick quiz. Drag the missing words to their correct place. If you're not sure, go to the previous screen to refresh your memory. Correct. For a positive displacement pump running at constant speed, the flow is constant, and so the head-to-flow curve should be like the red line. However, the actual head-to-flow curve will look like the blue line. The small change is known as slip and is due to the compressibility of the fluid and leakage. This curve indicates that even small restrictions in the designed flow rate can cause very high pressures to be delivered. A centrifugal pump uses the conservation of energy principle. It changes velocity energy into pressure energy. As the differential head increases, the flow rate decreases. The performance curve looks like this. A centrifugal pump incurs head losses due to friction. The friction is caused by the fluid changing direction when traveling through the pump and by clearances within the pump. These losses vary with both head and flow. Subtracting the losses from the ideal gives the actual performance curve for the pump. It's time for a quick quiz. Drag the missing words to their correct place. If you're not sure, go to the previous screen to refresh your memory. Correct. This graph shows the developed pressure of a positive displacement pump is dependent upon the power of the motor driving the pump, as supplied power equals useful power plus losses. Losses in a positive displacement pump are mainly mechanical, with the exception of a small loss due to leakage. For a centrifugal pump, as previously mentioned, losses vary with pump flow and developed head. This means that the useful power varies. A more useful curve is obtained from plotting efficiency to flow. Efficiency equals useful power divided by supplied power. The system should be designed to give the normal operating flow rate at the point of maximum efficiency. The pump section capabilities are measured by net positive suction head, or NPSH for short. Available net positive suction head, or NPSHA for short, is calculated from the atmospheric pressure, the static suction head, the friction loss in the pipe, and the liquid vapor pressure. Net positive suction head is the atmospheric pressure plus or minus the static suction head minus the friction loss in the pipe minus the liquid vapor pressure. The static suction head can be positive if the suction is above the pump. The friction head varies with the rate of liquid flow, so if we plot available net positive suction head to flow, we get the following curve. For a given rate of flow, a pump will have a net positive suction head requirement, or NPSHR for short, which is determined by the manufacturer. Net positive suction head requirement varies with liquid flow. These curves are an important factor when designing a system. If the pump operates to the right of point A, then the required suction head is greater than the available suction head. This means that vapor bubbles will occur in the suction pipe. As the vapor bubbles move through the pump, the pressure will increase and the bubbles will collapse. This process is called cavitation and can cause severe damage to the pump. It's time for a quick quiz. On which side of point A will cavitation occur? Click on the corresponding question mark. If you're not sure, go to the previous screen to refresh your memory. Correct. Operation to the right of point A means that vapor bubbles will form, and cavitation will be a problem. Finally, when considering reciprocating pumps, a further adjustment of net positive suction head is required due to the inertia of the suction pulses.